All right, we got a ton of vocab today, and we're going to go through it. But the first thing we need to do is we need to realize that mixtures get sorted up into 3 different categories. All right, there's 3 basic categories for mixtures, and those are sorted by particle size. Today we'll talk about the mixtures with really big particles, and we'll also talk about the mixtures with really small particles, but we will not get to the mixtures with medium-sized particles. Your textbook does not do them small, medium, big. It does them, or it does it big, small, then medium. Okay, so that's what we're going to do. We're going to do big particles, then small particles, and we'll do medium last, and that will end up being tomorrow. Because there's just way so many stuff to learn just about the small ones. Okay? All right. Mixtures. Big particles. So you have mixtures, types, big particles, medium particles, small particles. If the particles are big, then it's probably a heterogeneous mixture. If the particles are big, they're probably big enough that you can see them. Now, they can still be big and you not be able to see them. All right? You can't, if you have like dirt and water, the water looks dirty, but you can't actually see the particles of dirt. Does this sound familiar? Yeah. Those particles are still considered big enough to be a heterogeneous mixture because those particles of dirt will settle out. Does that make sense? But most of the time when I'm talking about a heterogeneous mixture, I'm going to give you examples where the pieces are big enough that you could conceivably see the pieces. Pizza. Granite. What? A salad. Is that what you said? Yeah. That's one of the things I usually come up with, salad. Okay? You can see the pieces. That's usually what we're talking about. Chicken noodle soup. Muddy water.
Chicken pot pie.
Chicken pot pie.
Yum.
Alright? These are things where the pieces are big enough that you can see them. And so they're going to be a heterogeneous mixture. Now, heterogeneous mixtures, there's 2 types. There's the type with a specialized name and the type without a specialized name. Alright? The type without a name usually just gets called heterogeneous mixture, even though there's more than one type. These are the things like salad, granite, pizza. You can see the pieces, but I don't care how long that piece of pizza sits on the counter, it's never going to settle out. Okay? Salads don't settle out. But they're still heterogeneous mixtures and you can see the pieces. And then there are the heterogeneous mixtures that usually have a liquid. Called suspensions.
Wait, but if in the salad there was something like ranch or something?
The trick is that a suspension will settle out when you let it sit by itself. And it will sort itself into layers by density. Okay? If you take muddy water and you shake it up, or if you take oil and water and shake it up, and you set it back down again, it will turn back into layers by density in a few minutes. Does that make sense?
Yeah.
Chicken noodle soup, where's all the good stuff?
Bottom.
At the bottom. Okay? So a suspension settles out. A salad, yeah, some of the stuff may dribble to the bottom. If you've got small bits and stuff may go to the bottom. But realistically, the tomatoes are going to stay on top if that's where the chef put them.
Yeah.
as long as you don't touch it. The egg is going to stay on top, or the croutons, or whatever. They're going to put wherever the chef put them in the salad when they gave it to you. If you don't touch it, that's how it stays. So there is heterogeneous mixtures that don't sort themselves out. And then there are heterogeneous mixtures that do sort themselves out. The ones that do sort themselves out have a special name, which is suspensions. Does that make sense? Examples of suspensions would be chicken noodle soup, muddy water is real common, oil and water, which would also fall under like salad dressing, snow globes. These are the examples of suspensions. But if I give you a salad, is that a suspension? No. Is it still a heterogeneous mixture?
Yes.
Okay? But it doesn't have a fancy name. It just gets heterogeneous mixture. Whereas suspension is also a heterogeneous mixture. It's just there's one that has no name and one that does. Does this make sense? This is pretty much it for the heterogeneous mixtures. This is pretty much the entire lesson for them. The pieces are big enough that you can probably see them. There's two types. There's a type with no name that just gets called heterogeneous mixture. And then there's a specialty type of heterogeneous mixture called suspensions. And then our examples. Does that make sense? Okay. Now I'm going to jump from big particles to particles that are itty bitty. So small, they're like the size of atoms. If the particles are the size of atoms, can you see them?
No.
No. Can you even see them with a microscope?
No.
No. If they're that small, can they go through filter paper?
No.
Yes. Yes. Yes, they can. All right. So a solution, which is our small particle mixture, does not get separated by filter paper because the particles are so small. It's kind of like trying to sort red M&Ms from green M&Ms using a screen. They're just all going to go through. Because the red M&Ms are not a different size from the green M&Ms. So you can't use that method to sort them. When you have salt water, the atoms of salt are the same size as the atoms of water. So the screen won't sort them. Does that make sense? All right. So, smallest particles, they're like atom-sized. If you can't see the difference, is this a heterogeneous or a homogeneous mixture? Homogeneous. And the specialized word here is solution. There are probably 15 vocabulary words that are specifically about solutions. And we are going to go through them now piece by piece. Okay? Yay. All right. Now this particular slide says what I've just said. A solution looks like one thing. If it looks like one thing, what's the vocab word? Homogeneous. Okay? But it really is two or more things. And the pieces are so small that you can't see them. And they're distributed evenly. Now it says the pieces are so small that they cannot be seen, filtered, or reflect light. So I've talked about seeing them. I've talked about filtering them. Now I need to take a second and talk about this reflect light thing. Cody, would you turn off the lights in the back, please? All right. This is my Sierra Mist, my old flat Sierra Mist. This is a laser pen. Now, when you take Sierra Mist and a laser pen, it doesn't really do anything. So here I'm showing you doesn't do anything, which most of you are like, whatever. All right, so for comparison, these are the super, super small particles, so small that they don't reflect light. Just to kind of show you what does reflect light looks like. This is Jello. This is a colloid. This would fall under the medium particles. Okay? Do you see how it looks like there's a lightsaber in there?
That's awesome.
Okay, can you see that? Sometimes I gotta get out of the light here. Can you see how it looks like there's a lightsaber in there? Okay? That's because the laser beam goes in there, but you can't see it unless it bounces off something and some of the light goes towards you. So if I'm pointing the laser beam that way, but you're seeing something and you're over there, that's because some of the particles are reflecting light. So this laser beam effect, that's reflecting light. Solutions don't do that. Okay? So that's what the reflecting light thing is. And here's the...
Oh, now I can see it.
Okay, see how it looks kind of like a little lightsaber is inside the Jello. Okay, everybody see that?
Yeah.
Anybody I need to get closer to get a better look? Everybody saw what I was talking about? Okay. Could you turn the lights back on, please? So, this is that slide here. So we've got all that stuff. You can step right in your hair, please, and take notes. And you need to take notes too. I don't care even if you are filming this. I'm filming this. I still want you to take notes. Because the writing, it helps you to think about what it is you're doing. Okay? Okay? This is something we've already talked about. Solutions are homogeneous. All the pieces look like they're the same. Now, the next three words come together. All right? The first word, and that doesn't say it here, the first word is solvent. Solvent is what there is the most of. Most of my examples, it'll be water. But there'll be a few times where it's not. For example, I might talk about air. Is water the solute if I'm talking about air? Is there water what they're the most of when I'm talking about air? No, okay? But we're looking at the solvent is what there is the most of. And usually it's the liquid in the equation. Most of the examples I give you are going to be the liquid. All right? And then the solute is what there is the least of. And that's usually the powder. Now, is it always the powder? No. Okay, if you look outside today, it's really super foggy. Air would be the solvent, and the water would be the solute. So sometimes things go backwards, but it's whatever there is the most of is the solvent, and whatever is the least of is the solute. The process of putting the solvent and the solute together and having them spread evenly into atom-sized particles, that is dissolving. Okay? So here's our dissolving happens faster when either you mix it, you heat it up, or you crush the pieces and make the pieces really small. Okay? So here, still looks a little cloudy, but if we gave it a few more minutes, this would clear up as all of the pieces would get so small that we could not see them anymore. Does that make sense? So these are our first 3 vocab words under solution. Solute, solvent, dissolved, or dissolving.